This is the final set of multiple choice questions on the amount of substance topic from AQA Chemistry. Up to around 60 in total now across 12 videos that are there. As always, I'm going to recommend that you're going to pause, try the answers for yourselves before you watch the solution. So, first one, let's take a look. And we can see here that we're dealing with ideal gas. We've been given volume, we've got a mass, we've got a temperature, and we're finding pressure. So PV is nRT. But we can go a little bit further on this one. We know that R is a constant. We also know in this case that V is a constant. So when I rearrange to make P the subject, I can see that rather than P is nRT over V, I can simply say P is proportional to number of moles times temperature. And we can use that very simple calculation to double check which of these is the highest pressure. First thing I'm going to do is work out the number of moles. I've been given a mass each time. So once we do that and we go through, we get 0.4, 0.1, 0.05 and 0.025 moles. We're then going to multiply each of those by the temperature stated in each question section. So 0.4 times 100, 0.1 times 100, 0.05 times 600, 0.025 times 1200. When we do that, what we find is the highest value, and therefore the highest pressure, is A. On to the next question. And once again, this is ideal gas. These are always a lot of work for very little reward because it is 1 mark you're going to at the end. But let's start by writing out the different bits that we know. You can see that we're missing V and we're missing N, but we can work out N. We've got a mass of Freon and we can work out its MR. 10.8 over 121, we have 0.089 moles. Now I need to consider conversion of units. Temperature's already fine, we're working out volume. My pressure, though, needs to be converted to pascals. Now I've done that, I can take my expression, V is nRT over P, and I can put all of my figures in. It takes me to 2.02 by 10 to the minus 3 meters cubed. That isn't an answer that's been provided, but we can convert that to decimeters cubed, and that gives us answer A, 2.02. Final question. And this is a relatively straightforward reacting masses question, or empirical formula question, sorry. The TiCl4 being reduced by the hydrogen, if the titanium is being reduced, it means we're going to get titanium metal. And we know, therefore, the hydrogen is going to take away some of the chlorine. So let's have a look. We know it's going to be a chloride of titanium that we're going to be left with. So let's draw out our table, Ti and Cl. Now, we've been told 68.9% of chlorine, so we can work out the percentage by mass of titanium. We can find the MRs, and we can use that to calculate the moles, and we get 0.649 and 1.94. Once I've got those, I simply divide by the smallest. It comes to 1 to 3. The correct answer is D. That takes us to the end of this video. Thank you for listening, and goodbye.